Hi, everyone. This is day 3 of Memfault's launch week. And once again, we have a huge release for you today. I'm so excited to talk to you about it. Yesterday, you may remember we talked about log management analytics. And today, I'm very glad to be presenting to you Memfault for Compliance. So let's talk about it. You know, we talk about it a lot. Building connected devices is very complex. And unfortunately, I'm here to tell you that it's about to get even more complicated. Regulators are cracking down on connected device security, and it's going to create a lot of work for all of us, and especially for those of you who are building devices that they're selling in the US and the EU markets. And you know, they're right to crack down. Connected device security sucks today. Let's not sugarcoat it. Look at this chart from the World Economic Forum. What it shows is the number of attacks against IoT devices per organization per day. So by an organization, we mean a business which is operating IoT devices on its network or in the fields, wherever it has to do work. And by attacks, we mean a cybersecurity, an attempt at cybersecurity breach or a successful security breach against these specific connected devices. And so if you read this chart, you'll see that on average, European organizations see 70 attacks against their IoT devices every day. This is a staggering number. Another company called Keyfactor published a report they called the State of IoT Security Report this year. And what they found in their reports during their surveys of industry leaders was that 89% of companies operating devices have been impacted by at least an attack. And on average, these attacks cost them $250,000 each. Sometimes millions or even tens, hundreds of millions of dollars. These attacks are no joke. And so I think given these facts, change was inevitable. In fact, I might even say that change is overdue. And so what is changing exactly? Well, the law is changing. From the UK to the EU to the US or even Singapore, major pieces of legislation are coming into effect in the next 2 to 3 years. For example, in the EU, the Cyber Resilience Act is expected to come into effect in 2026 or 2027. It will mandate specific security requirements for devices sold in the EU. But this is not the only law. The EU is also passing the EU Data Act, which will add, I think of it as the GDPR for devices. It gives data privacy and access requirements for all connected devices sold in the EU. The Cyber Trust Mark in the US is coming into effect at the end of this year and is a voluntary security accreditation scheme with pretty strict requirements. And while you'll still be able to sell products in the US without the Cyber Trust Mark, consumers will surely learn to look for the Cyber Trust Mark to understand which products they can and cannot trust. Last but not least, in the UK, the PSTI Act is adding requirements around how passwords are saved on devices and how unique they might be, as well as encryption and other security posture of the devices. All of these laws are going to massively change the landscape. These new security requirements extend across the entire life cycle of developing a device. This is not just secure design, and it's not just making sure that the device is secure at the moment you ship it. Instead, they need to be secured at all 3 stages of their life cycle. First, at the design stage, they need to be secure by design by, for example, encrypting all data, using encryption of all data in transit or at rest. They need to be secured at the time of deployment, They need to be, for example, deployed with no known vulnerabilities and with unique passwords deployed to all devices alongside with a secure default configuration. And they need to be secured through their whole lifetime with OTA update capability, with vulnerability detection, and with reporting systems so that you can actually track and inventory all the vulnerabilities that come in and when they might get fixed. This is a lot, and we're only, I think, giving you the high level overview, right? There's a lot more to these laws, which I'm sure you're going to dig into over the next year. And you might say, but Francois, shipping a connected device is already very complex. How am I going to cope? And you're right. It is already very complex. The average project takes 16 months to ship, but over 28 months for the more complex ones. Complexity is strongly correlated with how long a project takes to ship. Most projects, before these laws even come into effect, are already behind schedule. And when we poll leaders at IoT companies about why their projects are behind schedule, they will tell you that complexity is the number one reason. And this is data that was published by VDC Research in the State of IoT Software Development report earlier this year. And still, all of these projects are behind schedule, but 33% of all respondents tell us that they do not adequately test the cybersecurity of their products. And in fact, if you ask those folks who are already behind schedule, you'll find that even more of them, 50% of them, say that they don't adequately test the cybersecurity of their products. So counterintuitively, those that are the most behind are also those that test cybersecurity the least. So those projects are in for, even more trouble. So what now? What are we going to do? Well, we have a few ideas here at Memfault. First, it's time to change how we build devices by adopting best practices from the software industry. For example, open source. Embedded developers, I'm sorry to say, build too much from scratch. But you'll see that projects that rely more heavily on open source are more likely to be on schedule. Right? You'll see like 30% of like projects who use about 50% of their code as open source or third-party software are on schedule, whereas those that are behind schedule tend to use a good bit less. Using open source also allows us to collaborate with other ecosystem players on security. Look at what the Zephyr project is doing, for example. They track vulnerabilities publicly on their GitHub, or if you can subscribe to their CVE updates. They publish timely updates for their supported releases. And so, for example, this is adopting a project like Zephyr in your IoT product gives you a lot of security best practices without having to build all of these programs and all of this expertise from scratch. You're in effect sharing the load with other organizations who have the same compliance requirements as you. Outsourcing is the other piece of the puzzle. There is a key opportunity to outsource part of the compliance puzzle. Of course, at Memfault, we believe that outsourcing OTA and observability components are great ideas to stay ahead of compliance. And however you do it, companies that outsource OTA and observability are more than 3 times as likely to finish ahead of schedules than companies who don't. So I think the first recommendation here is use more open source and outsource more, because the reality is if we're going to have to do more work within the same schedule and the same amount of resources, we're going to have to find new ways to bring in third-party help in order to hit our milestones. So how does Memfault play into all of this? I think first and foremost, Memfault is a tried and tested enterprise-ready solution for OTA updates, fleet-wide monitoring, and remote issue investigation. Outsourcing these pieces of the stack to Memfault saves you time and lets your team focus on the work that truly differentiates your product. Because your engineers should be building things that makes your product great, not infrastructure that everybody uses. With Memfault, you'll see reduced delays and costs. Because instead of having to build something custom, you'll just implement a proven solution that already runs on tens of millions of devices. You'll have automated collection of issues and potential vulnerabilities, so you can quickly assess their impact and use near real-time fleet information to quickly understand the scope of the problem. You'll have a better way to triage problems and track their resolution with automatic data collection and the tracking of OTA updates, adoption across your fleets, as well as our issue inventory and our fleet's inventory. Last but not least, you'll be able to build better products by leveraging real-world data. Instead of having to guess how the product might be used or try to reproduce conditions in the lab, you just ask the data how it's doing by having it send you data directly from the field. Specifically considering the new regulation, there's a few features that I'd like to highlight. First is vulnerability identification and reporting. This is basically requirements across all these new regulatory schemes. You have to monitor your devices for potential compromise and vulnerabilities. You need to inventory those vulnerabilities, track them, and of course, you need to know when you've resolved them, in what software version, and whether your devices have applied the patch or not. You can automate all of this with Memfault using our monitoring, issue investigation tools, and our alerting systems. So for example, if you looked at the keynote yesterday, where we presented the new log management, you might use the Memfault's log management to search for a specific log line which hints at a compromise or a vulnerability in your fleet. So you can immediately see the number of times this log line is seen across your fleet and which devices are impacted by it. The ability to track issues and investigate them so that you can resolve them quickly is extremely important. And of course, it goes hand in hand with pushing security updates. OTA updates are the last line of defense from vulnerabilities. Memfault provides an enterprise-ready OTA solution, which lets you deploy targeted, controlled updates with full visibility. You can do stage rollouts. You'll also be able to have an audit log of which updates was active for which device when, and who on your team made those changes. You have built-in monitoring using our observability features, so you can track not just which devices are using the updates, but whether or not they're performing better than the ones before. And this, of course, is underpinned by a global content delivery network, which cost-effectively gets updates to your devices anywhere in the world extremely quickly. To fulfill some of the reporting requirements, you may want to use Memfault's device inventory. It lets you track all of your devices with their hardware version, their software version, their update history, as well as all kinds of attributes unique to your use case and your fleet, which you can personalize in Memfault. You can then search across all your devices and see which devices meet a specific set of attributes or see a specific set of attributes. And you can also do complex searches on multiple of these dimensions. Having a list of all your devices and their history is really important to understand which devices may be vulnerable or may be at risk in specific scenarios. And of course, monitoring software version adoption lets you know whether your last patch is being used across the whole fleet. Memfault even lets you associate a software bill of material with every software version, which you can then track back down to the device. So you can look up a device, pull up its software version, and then download its software bill of material. Last but not least, Memfault is GDPR and EU Data Act compliant. Through our platform, you can manage, access, and delete your diagnostics and monitoring data at any time. More importantly, you can at all times control what data is or isn't uploaded to our platform through all of the knobs available in our SDK and in the cloud. You can even scrub data on the device or in the clouds, and you can delete it, of course, on request, so that if a user of yours under their data acts rights asks for the data to be given to them or fully deleted, you can do that. Last but not least, Memfault is currently working on making it possible to host Memfault data locally in the EU. Historically, our servers have been in the US, and we know that this is important for our customers and our partners in the EU. As always, Memfault is built for embedded devices and works across every hardware, every operating systems, every connectivity mechanism. It is optimized for these devices, such as it doesn't consume too much power. It works even on very low power devices. It works on any connectivity setup, whether it is IP or non-IP, proprietary wireless, or just good old Wi-Fi. And it is very compute efficient, so they can work on highly constrained devices. Memfault uses our cross-platform SDK to collect the right data from your devices and buffer it for when connectivity is available. It uses our proprietary data routing system to get the data from your device to the clouds, no matter how many hops or what type of connectivity you use. And of course, it uses our high scalability infrastructure. So you can collect this data or push updates to tens of millions or more devices without having to build your own cluster of servers. Memfault is great, but don't take my word for it. Everything I've presented today is already being used by some of the best teams in the industry, and they say amazing things about us. Chris Merck from Bond, for example, said that if quality really matters to you, or if you really care that your customers get the experience they expect, then you should be using the best-in-class reliability solution for your industry. And in their case, the answer was clear: Memfault. Thank you for watching. Together, we can build more secure products without falling behind schedule. You can learn more about how Memfault can help you with compliance at memfault.com/compliance. And if you are in Embedded World in Austin, come find me at the Memfault booth. I would love to chat with you. Bye, everyone, and have a great day.